This experiment is to attempt to understand the behaviour of a composite material. What we have here is an epoxy resin that's impregnated with longitudinally and continuously aligned glass fibres, very, very small diameter. We have two samples that we're going to test, and we're going to put them into a 3-point bend test on this machine here that is capable of measuring load at the central point. The two samples that we have are 200mm and 40mm in span length. The overall length of each sample is slightly bigger than that. The 200 is from the supports as shown here, or 40 as shown there. The first thing we need to do is just measure the sample dimensions. We know the span length, that's noted. If we measure the depth of the sample will be loaded that way. So the depth of the sample is on screen now, 7.97mm. The width or breadth of the sample is 12.2mm. We shall now load this onto the 3-point bend jig. The crosshead of the machine will drive the central support downwards, and the load that is required to push the sample down will be recorded on the computer system and made available later in the form of a graph. So what's happened here is that the material has failed on the bottom surface because this surface is in tension. And we'll lift this in a second and just have a look at the fracture. So this is the sample we've just taken out. This is where the central support was pushing down. We can see at the bottom side there are whiskers, and these are the strands of glass fibre that have pulled out because this is in tension. And on the top you can see that there's a bulge in the surface on this side because this surface has been in compression. So if we now break this fully, we can see that you can see here which way around it was. On this surface we have fibre pull out, okay, and this is where the tension was, and you can see that this is a much more flattened surface, and this is because this region was in compression. So that's a typical failure, tension compression of a composite beam.